we are starting with the semantic thing. Then let's say the basis for one of the bases of the FIESTA platform is this use of semantics, and then what is always behind semantics is an ontology, and Rachid is presenting you the FIESTA ontology, let's say based or focus on which are the classes that have been defined and how we are using these classes, and hopefully you really find this slot useful. I assume that more questions and more doubts might come on this slot. So now, Rachid, again, the floor is yours, and go on whenever you want.
Okay, so thank you, Luis. I hope you can again see my my screen with this presentation, right?
We can, yes.
Okay. Okay. So what I will present is basically FIESTA ontology and the brief of what is used in this ontology and how we created it. I hope everybody knows about FIESTA and what it offers, so I will not go into details of what FIESTA is and what it offers and the objectives. So keeping that in mind, so keeping FIESTA objectives in mind, we have actually created this FIESTA ontology. This is basically observation oriented, so or the data that is produced by IoT devices is collected because of the objectives of FIESTA. So it's oriented in that way. So FIESTA actually, FIESTA ontology reuses concepts, and it does not create a new concept. So the ontology ecosystem or the semantics ecosystem is not overloaded with new concepts. What we have is we reuse existing concepts. We try to align most of those concepts that are there, most of the ontologies that are there, and reuse them and create one ontology, which is FIESTA ontology. We reuse concepts, we link them, and this is where the ontology comes in. Okay, so of course, FIESTA in FIESTA ontology, because it's data or observation oriented, we do not use all the concepts that are either coming from what you see here, SSN or IoT Lite, but we use a pruned version of these ontologies. So whatever concepts are needed, we use them. Whatever are not available in FIESTA ontology. So this is one aspect. So within FIESTA ontology, we have used number of ontologies and taxonomies coming from different sources. The core of FIESTA ontology is basically SSN and IoT Lite. Of course, QU is for the units and quantity kinds. So from SSN, most of the concepts are borrowed, and of course, from IoT Lite, some of them are borrowed. So from SSN, like deployment, the platform, the device concept, those are borrowed. Then, because of this observation-oriented and resource-oriented nature, the description, the metadata, we have this location information also available, and this is supported by the Geo ontology or the WGS84 ontology. We reuse some of the concepts from it. Then for the data values, we use dual, and for timing information, we use time ontology. On top, different to make it to address the heterogeneity and to address the federation, we have this taxonomy called M3 Lite. It's the Lite version of M3 ontology. This basically provides taxonomy for concepts like sensing device, quantity kind, units, domain of interest, etc. So this basically forms the core, and this is where different testbeds have to use the taxonomy that we provide in order to annotate their data and provide it to Fiesta so that people can reuse them much easily. On top of all this, we have also equivalent classes from 1M to M to actually link Fiesta with 1M to M. So it's this concept is also available. Okay, so next, this is the whole Fiesta figure, ontology figure. So how it is linked and what all concepts are there. So just give me a second. I think I'm missing something here. Okay. So basically, for SSN, as I said, SSN is the core, so you can see at the back. We have this deployment which is coming from SSN, the system, the platform, the device, the sensor, observation output, and observation value. And from IoT Lite, we have services, entity, virtual entity, metadata. I'll briefly speak about what these are. I will not go into details of all the concepts here, but some of the concepts. So, for example, like the deployment. Here, this is basically the testbed name. So, from where are resources, or from where which testbed are resources associated to, or from which testbed an observation is coming. This is deployment, and platform is the entity to which sensors and devices are attached. Sensing devices are various subclasses, and it has various subclasses which defines different types of sensors that are available within Fiesta, and ontology can be used. Of course, we will extend them as and when new requirements arrive. We can definitely extend them. And of course, this taxonomy for devices or sensing devices is basically coming from M3 Lite. Okay, so on top of all these, there is this metadata concept which you can assign to any resource. This can hold information like the frequency of data that is being generated, or any sort of metadata that you want to provide to Fiesta. Of course, we should not abuse this metadata concept and put everything on this metadata, because it will be very hard for the experimenters to reuse. So we have to be very careful when we use this metadata concept and annotate the resources that we have. For this metadata, the domain is just because of this reason left open. So there is no open domain. So you can in your annotations you can just link it to any domain. Okay. Now on top of this, there is the phenomena that a resource or a sensor senses. This is basically coming from the quantity kind. So we have the link which says has quantity kind, which links a sensor to the sensed phenomena. It can be noise, it can be like previously said, parking, or any temperature information. So any kind of environmental phenomena or such phenomena are present in quantity kind. And on top of the quantity kind, there is also units. So what is the unit supported? Like for noise, it's dBA. So we have all those kinds of information available as units. Of course, this the taxonomy for units is coming from Entry-Lite. Okay. So, okay, now once all these concepts are available, we actually link them based on different data properties or object properties. We have constraints in our ontology. These are basically cardinality constraints, where some of them are exactly one, some of them are at least one, and some of them are at max, min, and exactly one, yeah. And some are just like open. It can be zero. So, for example, a device can have multiple domain of interest, or at least minimum is one. So it's advisable that when people annotate their data, they follow this best practice and provide their annotations to Fiesta, and this is where the usefulness of the information comes, and experimenters can use this information. So this is the whole ontology picture. Of course, a sensor has observation. Sensor makes an observation, or observation is observed by a sensor. So these two links are there. Observation has sampling time, and it's basically everything is instantaneous. So we in Fiesta we assume everything is instantaneous, even if it's over a period of time. We assume that the testbeds are actually sending us information, which is kind of average or intervals, instance basically. So the data type is date time, and for observation value, we currently support double and Boolean. Of course, as and when we progress, if some more information is needed, that will be available, and you will have that information as an experimenter. So the whole ontology is divided basically into two parts. One is the resource graph, which actually is the upper part of the previous figure. And in the resource graph, you can actually have the information about a resource or a device, basically. It contains what the quantity kind senses, what's the unit, what is the platform the device is attached to, what is the deployment, etc. And the service. For the observation, of course, this is the graph, which is basically the lower part of the figure that I showed before. It basically has the observation, the instant at which the observation was taken, and the value, and the quantity kind, the unit, and some other testbed specific information like the measurement type and direction, if available. Of course, each observation has this position or location attribute also. Okay, so next is for the taxonomy. We have various or a list of concepts that are defined in the taxonomy. These are basically subclasses of either sensing device, quantity kind, units, domain of interest. So for sensing device, there are a lot of concepts that we have defined. We have tried to cover whatever current 4 testbeds supported. In case in future, like more testbeds will arrive, like in this open call itself. We will see if there is a requirement of new testbed, new concepts to be added. We will definitely update. So yeah, of course, you can go and have a look and see whatever your needs are. The documentation is available. Of course, I'm not going into details of each concepts here. So yeah, for sensing device, there are subclasses, as subclasses. Some sensor concepts are available, names are available for quantity and similar, units, cost, and domain of interest as well. So again, I showed this slide just before where I said, okay, there are some sample annotations that the ontology support for this resource graph. We have a simple annotation that is coming from SoundCity testbed that we have. So here you can see the main one is the device. We have this device, and this device is associated to deployment, which is SoundCity testbed. It is on a platform. It has a domain of interest, currently health, and there are a few others. I'm just showing one here. This device has actually 4 sensors, and out of these 4 sensors, I'm showing you one sensor. So that one is the sound sensor, and it has quantity kind sound, text sound, and or basically noise, you can say, and it has a unit in decibel. Okay, because this platform or this device has a location. For our SoundCity testbed, it's because it's large scale, anybody can join from anywhere. Initially, everything is kept to a default location, which is 0, and then this is where a best practice that I will further go on in the next couple of slides. You will see, in order to get the actual location of the resource, you should follow the observation link, because the observations will actually give you the latest location of the resource. Okay, so the sample annotations that we have for observation. So it's one of the many that we have. Of course, you can look into how David has also already presented this, and Tarek also, and then Fatah also. So one of them is here. It's a sensing device. Is basically made an observation, which is then following all the link that is defined in the ontology. So best practices to publish the data. Of course, we recommend data testbed providers not to publish data as a blank note, create individual for all concepts, have meaningful URIs for individual, respect the cardinality, and do not push unnecessary and fake test data. There is this validation concept or service that is also available. So testbed, all the observations that are available in IoT registry, or which David will talk in the next couple of sessions. All the data that is present there is actually validated by the validation service and complies to FIESTA ontology. So when the testbeds are producing annotations, they remove unused concepts, and the sensing device that is it forms actually the link between the observation graph and the resource graph. So the URIs should be same. Sorry. Then in the observation realm, we should use both made observation and SSN observed by, because of this, because of the issue that some testbeds, some experiments might only use observation realm, and some might only use resource aspects, resource graph. So it's always better to link. So this, as a best practice, is available, and as an experimenter, you can use either of the links to actually query the data. And of course, not to abuse metadata is one of the things. Best practices to query, as I said before, for mobility, or if you want to know the latest location of the resource or the device, you should actually look into the observations and get the location from there, rather than actually going taking the data, requesting the data from directly from the resource graph, and of course not query the entire data set. So of course not use select star as PO. So that's bad. That will definitely degrade the performance of the system. So this is something that is not advisable. Okay, so this is a sample query that I have made. So here it's divided into 3 parts. One is basically what is needed, and another one is basically getting the most recent information, the filter that is applied. I'm using this query in my experiment, which I will demonstrate sometime, probably in the next session, next couple of sessions, of course. And so here, basically, I'm getting sound information or the noise information and sound pressure level. So these are 2 concepts that I used. Yeah. And then some other resources, like the documentation, the Ontology documentation is available, both for FIESTA IoT and M3Lite. It's there at the playground in order to test the APIs that David will present. There is this paper also that was published last year. It's available, and of course the handbook. So yeah, so that's all from my side. I know there might be a lot of questions, so please go ahead.